Okay, hello everyone. It's nice to see you all here. My name is Denis Babichev. I work as a DevOps engineer in the company Hilbert team. And today I want to share with you our story, our journey, our customers' user case of how we decided to implement Clickhouse as a backend storage for Prometheus. But firstly, a couple of words about my company. You can scan a QR code if you want to contact us somehow. We are a global systems integrator. We help companies around the world to decrease their business costs, implementing best practices for DevOps, DataOps, DevSecOps, as well as we also do migrations from on-premises to cloud storages. And we also have our own educational courses. So moving further, some more words about me. I work mostly involved in development, consulting, maintenance, technical engineering, focusing on the delivery and DevOps part. Sometimes I write code, usually for automation tasks, but sometimes for the inspiration. I usually use a research approach, and I try to apply it, solving the tasks that I have to solve that come from our customers. And I'm also a huge fan of tennis. I really love this game. Okay, so to live our journey together with me, I think it's better to specify the topic disclosure for today's topic. So firstly, I will tell you how it all started, our customer's story, how he came to us with a task that he needs to store metrics, and how we decided to do this via Clickhouse. I'll tell you how we have done the market research, the problems we have faced, and how we finally approached to the Clickhouse as a solution, and which possible solutions to integrate your Prometheus with Clickhouse are today available. I also pay your attention to performance tests I have taken, and at the end of my speech, we'll head to the conclusions. And I will also provide you with QR codes where you can do by yourself your own performance testing. You could set up Clickhouse cluster, all the needed components, and try it yourself and decide whether you might need it or no. So, okay. The first bullet point, how it all started, but before I go next, I just have one simple question. Please raise your hands how many of you have already worked or implemented Prometheus into your production environments. Well, quite a few people. I thought there would be more. Okay, that's not a problem. Then we'll just pay a little attention to the architecture blueprints of how Prometheus works and which issues you will face after your loads will grow. So this is the basic architecture of the Prometheus. It consists of a server part, which consists of time series database. Job exporters are basically the hosts Prometheus is scraping metrics from. Grafana, well, it's a tool for visualizing your metrics, and alert manager for notifying you with the alerts. In time, when the amount of your services, of your hosts grows, it definitely will start to affect your Prometheus server because of the loads. And then it will reflect, of course, on Alert Manager, on Grafana querying, and so on. One way to solve this problem is to increase the amount of Prometheus servers. So like one server for a set of exporters you're using, but then you have to combine all of them in a single Grafana instance. And it might be a tricky part because it's not convenient, it's hard to do. And still, in time, when your load grows, you will face the same issues considering the high through outputs of metrics you will get into your Prometheus servers. So to sum up, easier to say, Prometheus just not designed for long-term storage metrics. It's good for real-time analysis, but poor for historical data analysis, I mean on long periods of time. It doesn't supply you with sharding and replication mechanism. It's not ready for high loads. It doesn't provide you with data sampling. It doesn't have scaling mechanism relying on data or load growth. So basically, this is a task our customer came to us. He needed a solution to store data for long periods of time, also considering some bullet points I will show you now. So the requirements were that the solution should be scalable and ready for high loads. It should be fault tolerant. It should have data processing mechanisms, sharding, and replication. So after we got the requirements from our customer, we went to the market, start doing our research, and these are the next systems, solutions we have tried, we have considered, investigated, and I'll tell you also the issues we have faced considering these systems. Okay, the first one was Denis. It's a basic also architecture blueprints of how it works. I won't stop long on each component. Basically, what we need to understand here is, well, in every upcoming system, 3 components: the ingestion one, the querying one, and the storing one. Here, the sidecar container is connected to Prometheus. Then it writes data to store component, and then all the store component is keeping the data in object storage. So basically, it's a S3 bucket or any other your self-managed solution that works on S3 protocol. And the query component then queries the data. So main thing I want to pay your attention here is the object storage, because it's one of the main things where you might face the issues. So let's consider the minuses. Well, and yes, architecture is quite complex. We will understand it more when we come to other things we have investigated. Not everyone is ready to store data in object storages. Clouds or cloud, it doesn't matter. If you want to use your own object storages, you still need engineers, you need power, you need people to manage and maintain object storages. And it's quite a trick also to find specialists that can be capable of doing this. Yes, it's basically the same thing, object storaging. One also important thing is that local storages, they are not fast, especially they start to get troubles providing data for long periods of time. So if you need metrics keeping for 1 year or even more, local storaging is a big issue here. And it's inflexible for data deletion and compression, and doesn't supply you with resharding options. Here I want to also comment a little bit. By resharding, I mean something that is under your control, that offers you to make a resharding manually by, for example, putting your data or migrating it from one shard to another. So with local storages, with object storages, sorry, it's not easy. So the next one we tried to investigate was Grafana Mimir. As you can see, the architecture is much more worse. It isn't easier than Denis. And the main point here is that it still uses object storages, and all the upcoming issues I have already told. Yeah, so the architecture is more complex. Same problems with object storaging, same inflexible rules for data deletion, compression. So basically, same as Denis problems, and no resharding also. And finally, we came to the, let's say, nowadays #1 solution for storing your metrics, VictoriaMetrics. Has any one of you already tried it or used it before? Okay, so two persons, same as with Prometheus, I guess. All right, so yeah, basically this is the architecture for VictoriaMetrics, the cluster version. It looks much easier. 1 scalable components VM insert for data inserts, 1 component for data selection, and scalable storage components. But yet, even though it looks easy, and VictoriaMetrics also provides a great performance results. It works perfectly on long periods times of data. It is scalable. It is really useful, really easy to install. But yet, there are some minuses that you should consider. The first one is about resharding that struggles with existing data. And here, I want you to hear me closely because it's a really important thing. So resharding in VictoriaMetrics works by consistent hashing algorithm. So for the metric, which consists of the metric name and the labels correlated with this metric name, the hash function calculates the number, which is then consistently stick to specific storage nodes. And it can be redistributed only after you scale your cluster, adding storage components to it. But it doesn't guarantee that this resharding, this recalculated resharding, will affect the metrics that you want. So you might have a small matrix and a very huge one matrix, and the resharding option will affect only the small one. So your old metrics, big ones, will still be left on previous storage components. So that is why sometimes, and VictoriaMetrics also says it on their page, you may run out of space on one of your storage nodes. And one more interesting and important thing is that you cannot rebalance your data. So after your data is written to one storage node, you cannot simply migrate it to another storage node if you want it. VictoriaMetrics say that they will implement a VMCTL component in their next iterations, but yet it's not production ready. So you should really consider it. Well, basically, it's just what I said about storage node and consistent hashing. And there is no direct SQL-like query support. You can use, of course, PromQL to build your analytics, the Prometheus language. But for SQL queries, you don't have such an opportunity, so less flexibility, let's say. So, all right, so bets are placed, decisions are made. Regarding everything we have investigated, we made our final decision and came to our customer. And the choice was VictoriaMetrics because it will basically answers all the requirements our customer needed. It's simple and fault tolerant. It's high performant with optimal use of resources. It is production ready and has a large community. So we set a call with our customer, suggested him our solution, and got his answer. No. So this guy was supposed to say no. Unfortunately, there is no sound for the computer, but it was no, yes. He came back with new requirements. The solution that we must implement should have ability to export data to the customer's ML system. It should be high performance, even on large metrics. It should have ability to use managed data storage, so it should have an ability to be cloudly available. Availability for manual resharding, option that I have told you in the VictoriaMetrics, and flexibility to build analytics above the metrics, and also sampling support for the data. Well, after these new requirements, we thought, why can't we try Clickhouse as a solution for these tasks? Just because everything from the requirements sounds like a great fit for Clickhouse itself. So why basically we have chosen it? Once again, it's fast, everyone knows it. It can itself be SML data storage and is made for large analytical queries. High performance and natively horizontally scaling, available in many managed solutions of many cloud providers. It originally uses Match3, the engine that VictoriaMetrics also uses, but originally it comes from the Clickhouse. And one very important fact, our customer is already using Clickhouse as well for other of his needs. And customers' engineers are more than acquainted with how Clickhouse works, how to manage it. So it's also a big plus. Then we went back to the market research and found two most feasible solutions for the Clickhouse to integrate it with your Prometheus metrics. The first one is called Curin, and the next one is the Carbon-Graphite Clickhouse components. So spoiler alert, the first one is pretty simple to deploy, but it has a really small amount of options, which wasn't suitable for our customer, and maybe it's more for get to know how to work with Clickhouse, but not to use in production. But yet a couple of words for this mechanism. It basically accepts data in different formats. It's compatible with PromQL, LogQL, Tempo API, uses Clickhouse as a storage backend. Basically, this is how it looks. Only one component responsible for data writing or data querying. So you just set a remote write URL in your Prometheus configuration, and Curin does it all for you. So to sum up the pluses, it's really easy to install. It's PromQL compatible. It's managed. It has an option of cloud solution. And the community is developing for Curin also. Minuses, free version, and it's the biggest minus, has limited query range support. I will show later an example of one of the basic dashboards, how it will look if you use basic version, well, the free one. No options to configure fault tolerance in the setting, so Curin creates merge tree tables by its own, and if you want to use replicating or distributing mechanism, you should to dive into the settings, figure out somehow what will suit you, and it's not really convenient, to be honest. Well, cloud version, although it's not free, it doesn't meet our customers' requirements as well. And this is basically how your basic node exporter graphic will look if you use Curin. So of course, it's not suitable for, I guess, anyone, because the most of the dashboards, the panels, they use aggregation methods, which are not available in free version. So right now, let's go back to the second solution, which we have implemented. It's a Carbon-Graphite setup. Once again, how many of you, if you haven't used like Prometheus, maybe you have used Graphite and Carbon setup? Can you raise your hands if you have used it? Okay, no one. Well, to be clear, it's just, let's say, a rival for Prometheus. It's just one way of storing your metrics. And this is how basically the architecture, including Clickhouse, will look. So Graphite and Carbon components are working, well, they have a special image which can be integrated with Clickhouse. Clickhouse itself has a native support for Graphite's matrix types. It's called Graphite Rollup. So before you configure your whole Clickhouse setup, you should, in the XML file, write all the needed Graphite Rollup points. And after that, everything will work. And you can use Carbon, put it as a remote write URL in Prometheus configuration, so your metrics will be perfectly driven to your Clickhouse. And through Graphite, you can make querying processes. So once again, the Carbon component is ingestion component. It writes metrics in Graphite format to Clickhouse. And Graphite reads metric from Clickhouse. And now I want you to pay attention of how you should configure your tables on the Clickhouse cluster before you can start writing metrics and start ingestion. So basically, you need to create Graphite merge tree tables. I wanted to show this slide to let you know that it's basically the merge tree table syntaxes. So while creating this table, you can already use all the Clickhouse power, such as sampling, partitioning, and so on. As well as creating the table just for storing your metrics, you can additionally create two more tables for index storing and for text storing. It is done for better performance, of course. Okay, so which things we should pay attention before going next to the architecture blueprint? Carbon-Graphite setup uses native merge tree engine. It's customizable for building, replication, and distribution. You can use partitioning and sampling, and I will tell you further how you can use it. You can separate text and indexes by creating new tables. So this is how your whole system is going to look after you create all the necessary graphite tables on your Clickhouse cluster. Merge tree graphite table, index table, and take tables. So with this setup, with this one node setup, you can start metrics ingestion without any problems. But the question you might ask me, how we achieve fault tolerance and scalability in such setup, because what I have shown you is working just for one node cluster. So, and here it's where the full power of merge tree engines of Clickhouse come on the stage. As it is a natively supported merge tree engine, you can build upon it replicated merge tree tables, and we'll go a bit later to it, distributed merge tree tables. So this allows you to configure your shards in a Clickhouse cluster. You can have 1, 2, or as many as you want of them. You basically create replicated graphite merge tree tables there, and that is how you can also already start writing your metrics. But of course, it's better to use a distributing mechanism, building it upon the replicated tables. So the distributed tables will be distributing the queries between all the shards. And in this blueprint, as you need to specify only one URL for the carbon components, you need to directly point it to shard 1 or shard 2 in that case, which is okay. Distributing mechanism will still work it out, but it would be better to put a load balancer in front of it and distribute your queries between all the shards. But what can be done even more better, and what we have implemented, is to put a separate front cluster, let's say it so, which will have all the distributing tables. This cluster will work as a load balancer itself, but not by another load balancing mechanism. It will distribute anything by Clickhouse engine. You basically use the one front-end URL to specify it in Carbon, and then distributed tables will distribute the incoming traffic through your shards. The big plus of this is also that you can separate your connections to database using this approach. So, for example, you can allow your analytics team to go directly only for front server, and the storage nodes might be available just for your ML systems or anything you need. So this is also a way of separating the accessibility of your cluster. And the next thing, which is more important and which gives you a big pluses above the VictoriaMetrics, is that you can define in the Carbon configuration in which shard you want to write your data. So, for example, you got a plenty new set of upcoming metrics. You just added a new shard in your Clickhouse cluster, and you want to write all the newly incoming metrics to this shard. You can achieve this by directly pointing Carbon to this shard, and the Graphite component, while it's querying the distributed tables, will still get and visualize this data in Grafana. So this is how you can directly point where your queries to go. you can use not only this approach, as well as configuring your weight distribution and custom sharding policy to have more flexibility distributing data across your shards. And one important note here is that you can also migrate data between your shards. It's not that easy, it's quite tricky, but Clickhouse has a documentation that describes how you can do this. At the end of my speech, I will leave a link. You can read it if you're interested. So, summing up everything we have discovered, let's consider the pluses and minuses of this solution. So, as a plus, complete support for PromQL and Prometheus API. Write and read streams are separated, both are scalable. All components are scalable. Well, to be more accurate, especially the storage component. Special Graphite Merge Tree engine, which contains all Clickhouse Merge Tree engine preferences. Customizable resharding, and everything can be fully deployed in the managed solution. Clickhouse itself and all the other components. Considering the minuses, quite tricky to set up. You have to dive deep into the documentation. Not too active community, but yet new releases are being published also. So this solution, to summarize, fitted great for our customer, and we have figured out that it's greatly suited as a part of the whole big data pipeline. So in case you want to build big data pipeline that includes ETL transactions, metrics readings, data marts, you can consider Clickhouse as part of the big data platform, and as well as we have find it out, you can store metrics there also. So happy customer, great implementation for him. Okay, let's have a couple of words of performance tests. It's quite tricky to fully show the results of the performance tests, so I'll leave you also a link where you can more specifically figure it out for yourself. But as what I have used as an input, there was a VictoriaMetrics benchmark. I will leave a link for it configured with configurable consistent amounts of node exporters, managed Clickhouse server deployed in the cloud, and every component, so Carbon-Graphite, Grafana, and Clickhouse shards, had 2 CPUs and 4 GB of RAM to run the benchmarks. And so key measurement nodes here you should pay attention to is that it's great for ingestion, so only starting with such a similar configuration, only starting from 400,000. I forgot to add a K here, 400,000 writes per second. The Clickhouse started to struggle. The CPU throttling appeared, the CPU peaks appeared. So below this value, below the amount of 8,000 hosts, it worked pretty well. Direct complex select queries to database provoke temporarily high peaks. So in case you want to directly access your database, you need also to pay attention to this. PromQL queries for 5 million series works really fast, 17 seconds to draw the results in Grafana. Rate over time queries work also really fast, but the long time periods queries in Grafana, like for months or for years, they took some time, and they consume quite a lot of resources. So you also have to pay attention to this. So to summarize, I wanted to help you figure out whether you need to consider Clickhouse as a solution for storage, for metric storage, or you can use VictoriaMetrics as it's still a great solution. It's more easy to install it. So for Clickhouse, as I have already told, it's really good for high ingestion rates. it can be considered as part of your data pipeline. Many solutions managed available, native merge tree, but still quite a long time for running performance select and running selects on a long periods of times. It's complicated to configure, and it's hard to backfill your old data. So basically, you need to investigate the architecture of how Carbon writes your data, or you need to use native Prometheus protobuf protocol binary, by the binary one, to backfill your data from one system to another. Well, talking about VictoriaMetrics, it's easy to configure. It has a perfect select time, even for years. It doesn't have a managed solution available. It's easy to backfill data and migrate it to VictoriaMetrics, but consistent caching, no manual control over your resharding, and specific for metric data in most cases. So that was all. Thanks for your watching. On the right QR codes, you can find some information about me. And on the left QR code, there are related links to where you can find, for example, a GitHub repository, where you can set up your own Clickhouse cluster, make your own benching, try it yourself, and figure for yourself out whether you need or you don't need to try Clickhouse as a backend for Prometheus. Thank you. All right.
Sorry if I missed that, but one of the requirements was that the client wanted to also use this as a storage for ML, I think. Yeah. So did they actually use it? Or I just wonder why would they want to use this same storage for the ML?
It was basically related to the point that customer already used Clickhouse as part of his data pipeline. So sorry for misunderstanding. Yeah, actually, it's not related to metric storage.
Thank you for your speech. Did I understand it correctly that your company is mostly responsible for some researches, and if some company which develops something, they want to outsource some researches about some technology or architecture solutions, they go to you, and what is the final result? It's just some instructions that you provide to them, or you made some configuration by yourself?
Okay, to make it clear, we will have quite a huge experience working with these metrics, but for some specific cases, it's just necessary to make some R&D and researches before we come back with a final solution to our customer. And yes, of course, we don't write an instruction and say something like do it yourself. We also provide with managed solutions our customer can use. Then we deploy anything there or deploy it on the customer's infrastructure. So of course we configure the whole system, and only with everything configured we come back with these results to our customer. So that's it.
No much questions, which is okay. Yeah, let's maybe spend some time and recharge. I think we all need it. Some outside. Let's get some.
Can I have 1 minute? Actually, absolutely. I have some small souvenirs for the ones who have asked the questions.
So, any other question?
Yeah. There is still one left. So this is the small wine from Serbia. Yeah, okay.
Even dumb one.
All right, I guess there should be another presence for questions to ask.
Thanks a lot, okay. Denis. It was a great speech, and yeah, everyone have a great time, and use it to recharge yourself.
Thank you.